Hello, Shenmukh,
Yes, sir.
Bhargavi. See, next one it is wave optics. Next chapter it is wave optics. One of the most important chapter and one of the scoring chapter. Okay, మీకు మోడర్న్ ఫిజిక్స్ తర్వాత ఈజీగా ఉండే చాప్టర్ ఇది. ఓకే, ఇన్ దిస్ వేవ్ ఆప్టిక్స్, okay, in this wave optics, initially we are having the, in the first category we are having Snell's law, and then Huygens principle, Huygens principle, okay, and then after Huygens principle, here we are having the, by applying the Huygens principle, we need to prove reflection of light and refraction of light, reflection of light and refraction of light by using the Huygens principle. Okay, in the reflection of light means we need to prove that it is angle of incidence is equal to angle of reflection, whereas in the refraction of light means we need to prove that if the light ray is moving from denser medium to rarer medium, angle of refraction, that is denser to rarer, then angle of reflection is greater than angle of incidence. And this is the first one. And second one, if the light ray is moving from rarer to denser, okay, angle of incidence is greater than angle of refraction. This topic, okay, this topic, that is entire this application, these three questions, okay, every time in the IPE board, okay, in your board, either in IPE or AP board, they are asking one question for 4 marks. They are asking one question for 4 marks. So most important, this Huygens principle they are asking in the 2-mark question. They are asking the 2-mark question. Okay, and thereby we are having the, in the JEE mains means out of the 41 years, okay, 2 years they asked on the Snell's law only, application of Snell's law only. Okay, next it is principle of superposition. Principle of superposition. Okay, and then we are having the definition of interference. Definition of interference. Okay, and types of interference. Conditions for constructive interference and destructive interference. Okay, next we are having Young's double slit experiment and its applications. Like in the Young's double slit experiment, suppose between the experiment we will have a thin film and its applications. This Young's double slit and this principle of superposition interference. Okay, on this principle of superposition and interference, previously they asked, okay, before 2000, from 2000 to not less than 2012, they asked on YDSC and applications. Okay, and finally we are having diffraction and polarization. Okay, and polarization. Okay, okay, diffraction and polarization. Okay, fine. Apart from this, we are having a topic called Doppler effect with respect to the light rays. Okay, I think in wave motion, you might study the Doppler effect with respect to sound waves. With respect to the sound waves. Okay, here we'll study with respect to the light rays. Okay, that is the entire picture of this chapter. Okay, so nowadays, from not less than from 2015 onwards, they are asking the question on this polarization. On this polarization, and this YDSC and applications are most important. In 2019 and 2020, they asked one question in the diffraction and polarization, and one question on the polarization. Okay, I think sometime before, 2 or 3 days before, okay, Rajesh sent 3 photos in the group. Anyone have you seen? Maths, physics, chemistry. Number of questions asked in 2002 to 2019. Anyone have you seen that one?
సార్ కలర్ పీడిఎఫ్ ఉంది సార్ మళ్ళీ పంపినా
పంపి మళ్ళీ పెట్టండి. జూనియర్ డౌట్ ఫారం గ్రూప్లో పెట్టాడు చూడండి. Okay, all of you must go through. Okay, in the last year, okay, mostly in the March before the COVID, I came in the month of February. I came for long-term students. Okay, for them I pasted in their classroom. Okay, one copy of maths, physics, chemistry at the girls' side, and one copy towards the boys' side. Maths, physics, chemistry. By that, you can see at the end of the column, we are having probability of asking question from that chapter. From that chapter. See, for electrostatics, current electricity, okay, mechanical properties of fluids, okay, probability it is 5%. More than 3% means you can consider it as one question as guarantee. By that, you can prepare yourself. Okay, there is no need that teacher will explain this chapter is important for JEE or this chapter is important. There is no need. You can decide yourself. You can plan for out of 25 questions, how many questions you want, you can plan it. Okay, all of you, please go through it and find which chapters you want to read. Okay, out of 25 questions, how many questions is your target? Okay, either 12 questions or 15 questions, whatever be the number, I don't mind. But out of the 12, 10 must be correct. That is what only I want. If you are aiming for 12 questions, out of 12, at least 10 must be correct. Then your score will be very high, above 95. Above 95. Okay. Like that in each subject, maths, physics, and chemistry. Okay, fine. Next one, it is, let us go to our topic, that is the wave optics. That is the wave optics. Firstly, before going to see the wave optics, we are having the, I think all of you knows about the angle of incidence, angle of reflection, and angle of refraction. According to the Snell's law, okay, it says that the first one it is, whenever the light ray is moving from, okay, denser medium to rarer medium. Okay, that is denser medium is having a refractive index mu1 and rarer medium is having a refractive index mu2. Since refractive index in denser medium is greater than refractive index in rarer medium, so I can say that mu1 is greater than mu2. Whenever a light ray is incident, at the point of incidence, okay, with respect to the substance, I can say that draw a normal. This is my normal. At the point of incidence, okay, with respect to the surface or with respect to the interface, I am drawing a normal. This n, it is the normal. With respect to normal, the angle made by the incident ray, it is the angle of incidence. Some part of the light ray will get reflected. Okay, this is my angle of reflection. and some part of the light ray will be goes to the other medium, that is angle of refraction. Okay, this one I can call as an refraction. Okay, okay, fine. It is my rarer medium. Light ray is going from denser to rarer, then we can say that the refracted ray will be away from the normal. Okay, now it is the thing that it is the thing that uh, I will apply the Snell's law. I will apply the Snell's law. That is, Snell's law states that the product of refractive index times the sine of the angle is constant. Is constant. Light ray is going from first medium to second medium or denser medium to rarer medium. So I can write it as mu d sine I is equal to mu r sine r. Here denser medium is having a refractive index mu1. So mu1 sine I is equal to mu2 sine r. So I can write as sine I by sine r is equal to mu2 by mu1. Since we know that mu1 is greater than mu2, then what will be the value of mu2 by mu1? Since mu1 is greater than mu2, that is mu1 by mu2 is greater than 1, right? Is it right? So mu2 by mu1, what will be the value? Gayatri, Gayatri.
Yes, sir.
Mu2 by mu1 by mu2 greater than 1, then mu2 by mu1, what will be the value? What will be the value? Just reciprocal kadamma. Just reciprocal. Mu2 by mu1 is less than 1. So sin I by sin r will be less than 1. Racha. So sin I is less than sin r. Apply inverse function on both sides. We can write as I is less than r or r is greater than I. Like this we can find, okay, the refracted ray will be away from the normal. Okay. Similarly for rarer medium to denser medium. Rarer medium to denser medium. Okay. Okay, fine. Now here it is that after the Snell's law, okay, like this we are having. Suppose mu d sine I, mu d sine I is equal to mu r sine r, mu r sine r. Okay, right? Suppose let us consider mu d is equal to mu sine I is equal to mu r. Let us consider it is an air, that is 1. Refractive index of air, it is 1. So 1 by mu is equal to sine I by sine r. The same thing, suppose if it is light ray is moving from rarer to denser, that is mu r sine I is equal to mu d sine r. If rarer medium is air and denser medium is suppose water, I am considering the medium as water, then I can write as 1 into sine I is equal to mu into sine r. So refractive index it is sine I by sine r. Sometimes we will consider this value, sometimes we will consider this value. Okay, that depends upon in the question you must see whether the light ray is moving from denser medium to rarer medium or rarer medium to denser medium. Rarer medium to denser medium. Okay, MSET or BitSat means they are asking one question on this one, Snell's law and Huygens principle. Okay, that's why. Next, Huygens principle. Huygens principle. Listen carefully. One of the most important concept with respect to this Huygens principle, they are asking conceptual based questions. Conceptual based questions. Okay. Okay, fine. Now, before going to see the Huygens principle, let me define the definition of wavefront. Wavefront. Okay. Suppose let us consider I am having a source. Okay. Source means it is an combination or collection of light rays. Collection of light rays. This source may be in the shape of spherical, cylindrical, or plane. See, in the ray optics, you might have considered the object as point object or extended object, right? Okay, point object. That means if the size of the object is very small, if the size of the object is very small, okay, that is very small means like nib of a pen. If you can see any gel pen, suppose gel pen, okay, this one, okay, or you can see like in some of the gel pens, they will write it as 0.6 mm and 0.7 mm, like, right?
Yes, sir.
Okay, if the size of the object is that much size, then we can call it a point object. Then we can call it a point object. Number one. And number two, collection of point objects can be called extended object. Extended object. Okay. So I'm having the source of any shape, this one. Firstly, let me take the spherical shape. Afterwards, I'll consider cylindrical and plane. Suppose in the spherical shape, from the source, what will happen? Light rays will emit in the form of a wave. In the form of a wave. In all the directions. In all the directions. Okay, like this. Okay, even here also. Even here. That means all these light rays, okay, will travel to a distance. Will travel to a distance. That is, I'm drawing it as up to a distance r. Okay, any one of the property. Okay, since it is moving in the form of a wave, we can say that amplitude or phase, okay, or wavelength, okay, will remains the same. The point at which all the light waves are having the same property, that is same amplitude or same phase, can be called as a wavefront. Can be called as a wavefront. Say for example, in your school days, you can see all the students will have the uniform before 10th class or before 8th class, you can see. So anyone from outside the school, okay, anyone from outside the school, they consider that by seeing the uniform, they will decide that it is the students are belonging to so-and-so school, suppose KB school, okay, or so-and-so schools. So all the students have same property, means same dress. That's why we're called an uniform. Okay, like that here also I'm having that. Okay, like that here also I'm having that all the light waves, all the light waves are having same amplitude. That is any property of the light wave. either amplitude or phase, okay, or wavelength, like this, can be called as locus of the points which are having the same amplitude, okay, can be called as a wavefront. Okay, this can be called as wavefront. Okay, and the points at which are having the same amplitude can be called as wavelet. Okay, this one, okay, and here, like this, these points can be called as wavelets. Okay, wavefront means the locus of all the points which are having the same amplitude can be called as wavefront. Wavelet means the point at which the light wave is having the same amplitude can be called as wavelet. Is it clear? ఎందుకంటే రాబోయే రోజుల్లో మొత్తం మనకి వేవ్ ఫ్రంట్ వేవ్లెట్ అనే వస్తుంది మొత్తం. Or shall I explain once more?
Once more. So ఒకసారి definition.
Suppose, see, I am having the source. From this source, light waves will emit in all the directions. Okay, up to a particular distance r. Okay, all the light waves in all the directions. Suppose here, in all the directions, are having the same amplitude. Okay, the locus of the points which are having the same amplitude can be called as wave front. Suppose if the source is a sphere or point source, then the wavefront will also be spherical. Sphere only. If the source is cylinder, then I will get a cylindrical wavefront. Okay, wavefront is defined as the locus of, okay, the locus of light rays in all directions which have same amplitude or phase. Can be called as wavefront. Okay, can be called as wavefront. Wavelet, that means the point at which light wave, all these are light waves only. Okay, all the light waves will have same amplitude, can be called as wavelet. This one, and this one. Okay, all these points can be called as wavelets. Okay, now here we are having the types of wavefront. Okay, this wavefront is divided into 3 types. One is spherical wavefront, and number 2 it is cylindrical wavefront, and number 3 it is plane wavefront. Okay, spherical wavefront, if the source is in the shape of a, okay, point source, or it is in the shape of a sphere, then we'll get the spherical wavefront. Okay, like this. Even you can see in the electrostatics, with respect to the point charge, at a distance r, okay, at a distance r, all the points will have equal distribution of charge, or electric field is same. The locus of all these points, there we call it as an intensity of electric field. Here we are concerned wavefront. This is spherical wavefront. Similarly, cylinder. Suppose if I am having an cylindrical source, Approximately, you can consider any tube light, either LED or normal. Okay, approximately it is in the shape of a cylindrical, right? Hello. So from this source, whatever the light rays are emits, okay, suppose here it is, from here. Again, if you join or if you do the locus, again we'll get the cylindrical wavefront. Okay, that is the locus of joining can be called as cylindrical wavefront. If the source, whatever be the source, okay, of any shape, is placed at far distance, suppose at a distance of 500 kilometer or at least 5 kilometer, then we can say that the light rays after traveling some distance will becomes as a plane. This type of wavefront can be called as plane wavefront. Even in ray optics, you can see while drawing the ray diagrams for mirror or lens, okay, what we consider it is, suppose if I'm having a concave mirror, if the object is at infinity, okay, we are saying that it is the light rays are parallel to principal axis. Anukunnara? And Gurtostonda, Srihita?
Yes, sir.
So whenever the light rays are parallel to principal axis, it will passes through the focal point or simply focus. Image will be formed at focus. Okay, na? Okay, this type of wavefront can be called as plane wavefront. Okay, okay, fine. Here we are having the properties of the wavefront. Okay, you can see that is incident ray and reflected ray will lie in the same plane. And second one, it is the angle of incidence or incident ray is perpendicular to the refracted ray. That is, angle of incidence and angle of refraction will be 90 degrees. Okay, like this you are having the properties. Okay. Depends on this, Huygens explained that. Okay, I can explain that. Whenever we are having a source, we'll have an wavefront will be generated. Okay, like this, in all the directions, we'll have a wavefront will be generated. So the locus is, it is the wavefront. Each wavelet will act as a secondary source. So each wavelet will again produces the light rays in all the directions. So again, it will comes as a secondary wavefront. Okay, this can be called as secondary wavefront. So Huygens principle, it says that, okay, each wavelet on the primary wavefront or simply wavefront will act as a secondary source, which leads to the formation of secondary wavefront. Okay, and the points at which, okay, amplitude or phase are equal, that can be called as secondary wavelets. Say for example, Ashish, Leda, next Veda. See, sometime what will happens. Say for example, let us consider in alternating current. Okay, there is a topic called LCR in series. Okay, Okay, whenever I explained in the class, okay, suppose in the class 20 students are there, okay, unfortunately, only 5 students understood, 15 students didn't understood. Then what will happens, these 5 students, I am explaining to all the 20 students, whatever the points are there, I am giving to all the students. Okay, so only 5 students they understood. So the points, the locus of all the students, source it is teacher. He is giving knowledge to all the students, it is same. But only 5 students are having the knowledge. Okay. And then these 5 students will act as a secondary teacher. See, these 5 students will act as a secondary teacher. They will explain to the remaining 15 students or 10 students. So we can say that the secondary wavefront or secondary wavelets are those 5 students. With that, what will happens after after getting this one, then the all the students will get understand. All the students will get understand. Okay, okay, fine. So that means whenever the teacher is explaining, whenever the teacher is explaining, okay, whatever the 5 students are understanding, that can be called as primary wavefront or simply wavefront. These primary wavefront, okay, will act as a secondary source. Secondary source. Okay, right? Okay, okay, fine. And then next one, it is that, okay, so Huygens explained about the secondary wavefront. That is, whenever the light rays are incident on optical object, on any optical object, either it is a mirror or prism or lens, okay, or glass slab, okay, or microscope, telescope, any optical object, then what will happens, each light ray will act as a secondary source. Each light ray will act as a secondary source, okay, which causes to form the secondary wavefront, which causes to form the secondary wavefront. Okay, okay, fine. Now, here it is that we are having a secondary wavefront. Okay, now let us consider I am having an interface such that this is the denser medium and here it is the rarer medium. Okay. Whenever a light ray is incident, suppose this one A and then B. With respect to this incident ray, will have a wavefront. Will have a wavefront. Okay, that is I'll call it an incident wavefront. Incident wavefront. Okay, suppose let us consider that incident wavefront is like this. Incident wavefront is like this. Okay, CB is my incident wavefront. Whenever a light ray is incident, then some part of the light ray, okay, will be reflected and some part will be refracted with respect to the normal. With respect to the normal. Let us consider BC is the refractor ray. BC is the refractor ray. Okay, fine. Hello, is it fine? Okay, now. Okay, whenever a light ray is incident, okay, with respect to the interface, then some part of the light ray will be reflected and some part will be refracted. Will be refracted. Okay, suppose let us consider BE is the reflector ray. With respect to this reflector ray and refractor ray, we are having that, okay, we are having that wavefront. We are having a wavefront, which we are called an incident wavefront and refracted wavefront. Okay, according to the properties, it says that incident wavefront and refracted wavefront are perpendicular to each other. Are perpendicular to each other. Okay, perpendicular to each other means like this. Okay, okay, fine. Incident wavefront and this one. Now, by applying the, okay, here it is with respect to normal, this incident wavefront is having an angle I. Okay, by applying the this one Snell's law, I can write as mu d sine I is equal to mu r sine r. Same as like before. Okay, see here the first page, second page, like this. The same derivation will get here. Okay, that is sine I by sine r is equal to mu r by mu d. Since mu d by mu r is greater than 1, because refractive index in denser medium is greater than refractive index in the rarer medium, right? Is it fine? Is it fine?
Yes, sir.
అంటే mu d by mu r is greater than 1 అని రాయచ్చా?
Yes.
Okay, I got it. Next, here we can say that mu r by mu d, which is less than 1. So sine I is less than sine r. That means I is less than r. Okay, that is what this one refraction of light. See in our first slide, refraction of light. Refraction of the light. Okay, here you should see in this question you should carefully understand what is the incident ray and what is the incident wavefront. That is number one. Second point, incident wavefront and refracted wavefront always perpendicular to each other. Okay, such that the angle of incident wavefront and refracted wavefront will be 90 degrees. Will be 90 degrees. Okay, that is theoretical one. Okay, and similarly, if we are having only, if this surface, see here I am having refractive medium. Okay, suppose if I interchange the mediums, if the light ray is coming from rarer to denser, then we can prove it as an I is greater than R. Refracted ray will be greater. Okay, suppose let us consider perpendicular means, suppose from here it is perpendicular. That means suppose here like this. This one. This is my refracted wavefront. Okay. Okay, fine. That is the refracted wavefront. So this angle with respect to the normal, this is my angle of refraction for refracted wavefront. Refracted wavefront. Okay, no? Okay, fine. Now here it is that suppose if the rarer medium, if this surface is polished or silvered, okay, then we don't have any refraction. We'll have only the reflection. Then we will see the incident wavefront and reflected wavefront. Incident wavefront and reflected wavefront only. Okay, na? Hello? Is it fine? Is it fine? Incident wavefront and reflected wavefront. Okay, by applying the Snell's law, we can say that it is angle of incidence equal to angle of reflection. That one. Okay. Next, it is the point. It is principle of superposition. Principle of superposition. This Huygens principle and application of Huygens principle in reflection of light and refraction of light. It is important topic for board. Okay, in the entrance, either in MSET or BITSAT or JEE mains. Okay, they ask theoretical question only. That is application of Snell's law only they asked. Application of Snell's law only they asked. Okay. Now, suppose let us consider a light wave is moving. Okay. And very important that it is, understand that light ray can travel in air or vacuum as well as a medium. If the light ray is traveling air, then the speed will be 3 into 10 power 8 meter per second. If it is traveling in a medium, then we are having that it is speed of light air by property of the medium. The property of the medium is explained by the refractive index. In electricity, the property of the medium it is permittivity. Whereas in the magnetism, the property of medium it is permeability. In optics, the property of the medium is mu. That is, in the medium, why we need all these properties means whenever the light particle or charged particle is moving, then its physical properties or chemical properties or biological properties or mechanical properties, any one of the property will be changes. Here, I am taking the velocity or speed, how the light ray is moving in air and how the light ray is moving in medium. Okay, say for example, Rajesh, 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 ఇప్పుడు ఇప్పటిదాకా మీరు అట్లీస్ట్ నాట్ లెస్ దాన్ బిఫోర్ 10 days మీరు ఇంట్లో కూర్చున్నారు. ఇంట్లో ఏమైనా చదివారా మీరు?
లేదు సార్.
అవునా? ఎప్పుడైతే కాలేజీ రావటం స్టార్ట్ చేశారో ఏమైనా కొంచెం ఒక క్వశ్చన్ అయినా చదువుతున్నారా?
ఒక్క క్వశ్చన్ కన్నా ఎక్కువే కదా సార్. పర్ డే మినిమం 5 క్వశ్చన్స్ చదువుతున్నాయి.
నువ్వు కాదులే, ఇక మిగతా వాళ్ళు ఉన్నారుగా మీకు, ఆశీష్, శ్రీరాము, వీళ్ళ సంగతి. కనీసం వర్స్ట్ కేసులో ఒక్క క్వశ్చన్, ఐదర్ ఇట్ ఈస్ ఏ 2 marks ఆర్ దిస్ వన్ వీ కెన్ కన్సిడర్. ఓకే, ఒక్కో క్వశ్చన్. అంటే ఇక్కడ చూడండి, మీరు ఇంట్లో ఉన్నదంటే అంటే ఎయిర్. ఓకే, ఇక్కడ ఇన్స్టిట్యూట్కో కాలేజ్కో వచ్చి చదవటం అనేది మీడియం. ఓకే, సో ప్రాపర్టీస్ విల్ బి చేంజెస్, మీలో కూడా చేంజెస్ వస్తాయి. ఓకే, దట్ వీఆర్ కన్సిడరింగ్ ఇట్, ఓకే. దాన్ని మనం రిఫ్రాక్టివ్ ఇండెక్స్ అంటాం. ఎంత స్పీడ్ తోటి లైట్ రేస్ అనేవి మీడియంలో మూవ్ అవుతాయి, దాన్ని అంటాం. సో we can say that it is mu is equal to C medium. In some textbooks they will indicate with V. C air means that is indicate with C. So mu is equal to C by V. Mu is equal to C by V. Okay, okay, fine. Now it is refractive index. Whenever a light wave is moving, you can see we are having the properties like amplitude and wave vector, and we are having an angular frequency omega t. Okay, omega t. Okay, now I'm having the displacement. The displacement of a light wave we can write as a times sine of omega t minus kx. Wave vector, what is the formula for wave vector? Wave vector formula
1 by
wave vector formula Umar, Bhargavi, Shenmugh,
Sir,
wave vector formula.
అంటే K కా?
Huh?
K నా? Value
No,
of
no.
K. 2 pi by lambda.
2 pi by lambda. Avuna? Omega means angular frequency. What is the relation between omega, K and V?
V equal to omega by K.
V equal to omega by K or omega equal to KV. Umar, Bhargavi, చదవట్లేదు వేవ్ మోషన్. భార్గవి లేదా? సరే, ఒమేగా ఈక్వల్ టు కేవి. మీకు వేవ్ మోషన్లో ఫస్ట్లో మీకు వేవ్ ప్రాపర్టీస్ ఆర్ వేవ్ పారామీటర్స్ వస్తాయి. ప్రెషరు, ఇంటెన్సిటీ, ఓకే, ఫోర్స్ అండ్ తర్వాత ఎనర్జీ డెన్సిటీ, ఇట్లా 4 పారామీటర్స్ వస్తాయి. ఓకే, అవి సౌండ్ వేవ్కి ఏవైతే కనుక్కున్నారో లైట్ వేవ్ కూడా కనుక్కోవాలి. ఇంటెన్సిటీ ఆఫ్ ఎ లైట్ వేవ్ మోస్ట్ ఇంపార్టెంట్. అలాగే ఇంటెన్సిటీ ఆఫ్ సౌండ్ వేవ్, okay. X, it is the position, okay, instantaneous position. Suppose if a wave is traveled up to here, this is my horizontal distance, correspondingly this is my displacement y. Omega t means instantaneous time, okay, up to here it is x. Okay, now let us consider that, or let me define about the phase. Okay, suppose, see here, first wave is moving from here and another wave, okay, is also moved from here, such that there is a small change in the amplitude. Okay, phase is defined as the angular position of the two particles with respect to a fixed point or fixed axis. Okay, you can see whenever you are having the offline classes, okay, even you can see in the last year, you can see that some of the students will see the board or will watch the board, okay, perpendicularly or straight to the board. Some of the students, they will watch like this, that is at an angle 0 to 30 degrees. Okay, some of the students, they will do like this, they will see. Okay, so there is a change in angular position of the students, the student who is watching the board perpendicularly, and there is a student who will watch at an angle either 30 degrees or 120 degrees. Okay, either in acute angle or in obtuse angle. They cannot watch the board which is greater than the 150 degrees. Okay, maximum they can have the angle. So that angle we are calling it as phase, that angle. So this one, the change in the angular position of the two waves. Okay, in oscillations means we will say the change in angular position between the two particles. Okay, suppose if the two waves are having the same amplitude and starting from the same position, we can say that phase will be zero. And even you can see in the alternating current, especially when the alternating current passes through a resistor, then we are having the graph. This is my voltage, like this, okay, and current graph will be like this, There will be a change in the amplitude, but both are starting from the same position. That is the phase difference, the change or difference in the angular position of these two quantities, voltage and current, it is approximately 0. approximately 0. This is what we studied or we derived. You can see, okay, in the alternating current. Okay. So let us consider one wave is having this one. Suppose let us consider another wave. I'm having one wave as like this. This is the wave 1. Another wave. Suppose I'm having like this. This is my second wave. Okay. Okay, fine. Here it is 0. This is y and this is x. First wave, sorry, x. First wave, I can represent it as y equal to sin x graph, right? Y equal to sin x graph. Is it right? Next, in the second one, okay, second one, anyone tell the what will be the shape of the graph?
Cos x.
Cos x, y1, y2. So what will be the change in the angular position? That is the phase difference between sin x and cos x. What is the phase difference between sin x and cos x graphs?
Pi by 2.
Right? So I can write as phase difference between sin x and cos x as pi by 2. Pi by 2. So now in the principle of superposition, that is, we are considering the two waves. That is A times, suppose A1 having an amplitude. The two waves are having the same angular frequency. And there is a phase difference between the two waves as phi. Phi is my phase difference of the two light waves or two particles. So according to the principle of superposition, if these two waves are superposed, then the resultant displacement y is equal to sum of the displacements of the two light waves. Sum of the displacements of the two light waves. That is y is equal to a1 sine of omega t minus kx plus a2 sine of omega t minus kx plus phi. For simplicity, I am considering that let omega t minus kx is equal to theta. Instead of every time writing as omega t minus kx, okay, I'll write theta. Afterwards, at the final stage of derivation, I will replace theta as omega t minus kx. Omega t minus kx. Okay, fine. So I can write as a1 sine theta plus a2 sine of theta plus phi. Right? Okay. Now, this sine theta plus phi, I will expand it. Same type of derivation you will have in wave motion also. Wave motion also. Avuna? Umar,
Sir,
వచ్చిందా?
sir,
ఏమైనా గుర్తొస్తుందా? భార్గవి గుర్తొస్తుందా? శ్రీహిత, గాయత్రి, right? Expand this sine of theta plus phi as sine theta cos phi plus cos theta sin phi, and take sine theta common, a1 plus a2 cos phi. Okay. Now I am considering that we are having the equation sine theta into a1 plus a2 cos phi plus cos theta into a2 sin phi. I am considering the condition that let a1 plus a2 cos phi is equal to r amplitude of the resultant wave, r cos alpha. Okay, and then a2 sin phi, I will consider it as r sin alpha. So I'll replace it. Y equal to sine theta into r cos alpha plus cos theta multiplied by r sin alpha. So if we consider r common, sin theta cos alpha plus cos theta sin alpha. How can I write? Sin theta cos alpha plus cos
Sin
theta
of
sin
alpha plus
alpha.
theta.
Sin of,
Sin of
we can
alpha
write
plus.
as theta plus alpha. Theta means I consider it as omega t minus kx r into sin of omega t minus kx plus alpha. So if we combine or superpose two light waves, again the resultant wave will also be in the same form. We got it, right? Hello, is it right? Is it right? Okay. Now we consider that a1 plus a2 cos phi as capital R cos alpha and a2 sin phi we consider it as capital R sin alpha. Squaring and adding, that is r square cos square alpha plus r square sin square alpha is equal to a1 plus a2 cos phi whole square plus a2 sin phi whole square. Okay, that is take r square common, cos square alpha plus sin square alpha, that is equal to 1, right? Cos square alpha plus sin square alpha equal to 1. So r square equal to, expand this one, a1 square plus a2 square cos square phi plus 2a1 a2 cos phi plus a2 square sin square phi, a2 square cos square phi plus a2 square sin square phi. How can I write? Take a2 square common. So a1 square plus a2 square plus 2a1 a2 cos phi. Antena?
Yes,
R
sir.
square. So r is equal to under root of a1 square plus a2 square plus 2a1 a2 cos phi. That is the magnitude of resultant amplitude. Suppose here we are having resultant amplitude, it is this one. a1 square plus a2 square plus 2a1 a2 cos phi. Now I want to find the conditions for when the resultant amplitude is maximum. Okay, a1 and a2 we are not changing the values. When phase difference between the waves is equal to 0 degrees, then maximum amplitude, I can write it as a1 plus a2. Okay, now when phi is equal to 90 degrees, then resultant amplitude will be under root a1 square plus a2 square, right? When phi is equal to 180, that is cos, minimum value of cos phi, it is minus 1. Cos 90 means 0. So resultant amplitude will get minimum, that is a1 minus a2, right? Okay, now from these I can find the r sin alpha and r cos alpha. From this I can find tan alpha, that is r sin alpha by r cos alpha. R sin alpha means a2 sin phi by a1 plus a2 cos phi. So tan alpha is equal to a2 sin phi divided by a1 plus a2 cos phi. Okay, so alpha is equal to tan inverse of a2 sin phi divided by a1 plus a2 cos phi. a1 plus a2 cos phi. Suppose if a1 is equal to a2, then alpha is equal to tan inverse of sin phi by 1 plus cos phi, right? Hello? Antena? Gayatri?
Yes.
Then alpha is equal to tan inverse of sin phi. Okay, I'll write into submultiple angle. That is 2 sin phi by 2 cos phi by 2. 1 plus cos phi. I'll write into submultiple as 2 cos square phi by 2. So we'll get it as tan inverse of tan of phi by 2. So alpha is equal to phi by 2 when a1 equal to a2. When a1 equal to a2, directly we can write as alpha equal to phi by 2. Okay. So here we are having the resultant amplitude. Resultant amplitude. In order to have the resultant amplitude, okay, we are having the condition that phi is equal to 0 degrees. Now let us introduce the term called path difference. Path difference. Path difference is defined as the difference in the distance or path, the difference in the path traveled by any two reflected light rays or refracted light rays can be called as path difference. Can be called as path difference. Say for example, suppose from here I want to go to Bombay. From Hyderabad, I want to go to Bombay. Okay, one person will take or will go from Hyderabad to Goa and Goa to Bombay. Another person will goes to Hyderabad to Bangalore and Bangalore to Bombay. Right? Two different routes. Then what will happen? The path difference between these two persons. It is what is the distance traveled between the two persons. Suppose from Hyderabad to Goa and Goa to Bombay. Okay, it is having, suppose let us consider 800 kilometers. And from Hyderabad to Bangalore and Bangalore to Bombay, it is having 700 kilometers. So path difference will be 100 kilometers.
Yes, sir.
Okay, so that is the path difference. Path difference is indicated by delta. It is defined as path traveled by light rays, okay, of two or more, either reflected light rays or refracted light rays, or one light ray is reflected, one light ray is refracted. ఏవైనా ఒక టూ లైట్ రేస్, ఒకటి రిఫ్లెక్టెడ్ అవ్వచ్చు, ఇంకోటి రిఫ్రాక్ట్ అవ్వచ్చు. లేదు రెండు రిఫ్లెక్టెడ్ అవ్వచ్చు, లేదు రెండు రిఫ్రాక్టెడ్ అవ్వచ్చు. ఓకే, ఎనీథింగ్ ఇట్ కెన్ బి కాల్డ్ యాజ్ పాత్ డిఫరెన్స్. సపోజ్ ఇట్లా నాకు వేవ్ ఉందనుకోండి. Whenever a wave completes one cycle, then what will be the total angle? I can write as phi equal to 2 pi. For one wave, I can say the wavelength or distance traveled, it is lambda. Hello? Avuna?
Yes, sir.
For one complete wave, okay, the distance traveled by the wave is lambda. Okay, and the angle, it is 2 pi. Now I want to find for one unit dimension, 1 meter or 1 centimeter. Okay, then what is the angle? that is 2 pi. This 2 pi by lambda will gives the or will explains about number of waves that are traveled in unit dimension. This we are calling it as wave vector, right? Okay. Okay, fine. Now, for unit dimension, it is this one. For if the distance traveled is delta meters, then I can write it as 2 pi by lambda into delta. That is, for 2 pi or for lambda, it is 2 angle, it is 2 pi. For delta meters, what will be the angle? So phi is equal to delta by lambda into 2 pi. That is phi is equal to 2 pi by lambda into delta. That is the relation between path difference and phase difference. Most important relation, and please remember all of you. Suppose let us consider if phi is equal to pi by 2. What will be the value of lambda? Sorry, what will be the value of delta? That is, use the above relation. That is, pi by 2 is equal to 2 pi by lambda into delta.
Lambda by 4.
Right? Clearly, for 2 pi, we are having lambda. Here we are having pi by 2. That is by 4 only now. Okay. Suppose if lambda equal to, if delta is equal to lambda by 8, then find the value of phi. That is, substitute here, phi is equal to 2 pi by lambda into lambda by 8. That is, phi is equal to pi by 4.
Pi by
Okay, like this we'll convert. If they give the phase difference, then we'll find the path difference. Okay, till here, please remember. Okay, Udaykant,
సార్
ఇది అప్పుడే వచ్చారా?
క్లాస్ అయిపోయింది సార్.
అయిపోయిందా?
5 minutes తర్వాత రావాలి సార్.
ఒక 5 minutes అన్న.
ఓకే సార్.
Okay, till here, please remember the same conditions we'll use to find the conditions for interference. That is constructive interference and destructive interference. Okay, remember the relation phase difference and path difference 2 pi by lambda into delta. 2 pi by lambda into delta. Okay, fine. Till up to here, please remember, and we'll continue in the next class.